Hi there, welcome to edupediaworld.com. You're watching the videos on surface area and volume. So in this video, we'll discuss what is a volume of right circular cone. Like in the previous video, we have discussed about the surface area of cone, right? Now in this video, we'll discuss the volume of right circular cone. And we'll also discuss some of the examples and which are very important from the exam point of view. And we'll also discuss why we need to learn more about the volume of right circular cone. We'll also see some of the real life example which can actually help you to better understand how we can like calculate the volume of right circular cone, why we need to learn more about right circular cone. So this is all about this video now. So let's get started first with introduction. Right now, introduction, volume of cone. As you can see over here, this is a cylinder, right? You can see very clearly, and this is cone. Now if you can see properly, cylinder and cone, they are somewhat similar. Instead, that cone has a slanting height, whereas cylinder has a straight height, right? So this means, you know, the volume of cone is actually derived from cylinder. It's a part of cylinder, or we can say that we have cut it a cylinder, or like we have tapered a cylinder to get a cone, right? So these volumes are actually very much related. So however, for volume of cylinder, we will learn more about them in the coming videos, in the next videos. But in this video, we'll learn more about the volume of cone, right? Now, the volume of cone is given by 1 by 3 pi r square h, right? So you all know that volume is a capacity, right? Capacity of any object getting a fill, how much we can fill in a container on a vessel, right? So why we need to learn more about volume of a cone? Let's say if you are making a soft ice cream or any or cone ice cream, you must have it in the market. We'll see the examples, we'll see the real life example, then you can actually know how much quantity to be filled, right? So let's see some of the example, real life examples. Now here we have real life example. Let's say this is a cone, right? Now if you know the volume, how we can, let's say how we can calculate the volume of cone, then you can actually know, you can actually know how much material has to be filled in the cone to get the ice cream, right? So if this is the importance of knowing how we can calculate the volume of cone, right? Now let's see another example. You can see this is a funnel like you must have seen it, which is used for like filling some, we can say, petrol, diesel or kerosene oil, right? So this is a funnel which is used, very commonly used, you must have seen the market, right? Now this funnel is not actually a proper cone. You can see it over here, we have a different basis, right? Which is, this base is not pointed. However, in cone the base is always pointed, right? So you will learn this, like this type of cones, these type of cones are actually known as truncated cones, right? You will learn about more about this in the higher classes, how we can calculate the area of area and volume of truncated cones, right? So you need not to worry right now. However, my point is, like, if you know how we can calculate the volume of this truncated cone or this cone, the complete cone, then you can actually exactly know how much petrol, diesel can pass through this funnel, right? So this is actually importance of knowing the volume of cone, right? So let's do some of the examples which can actually help you to learn more or understand concepts better for volume of cone, right? Now, so let's discuss the example number 1. Now the example says that the height and the slant height of a cone are 21 centimeter and 28 centimeter respectively. You need to find the volume of cone, right? So let's say how we can do this question. So first of all, we need to draw a cone. So let's say we have a cone like this, right? So this is a cone, and let's say this is a radius r, this is height, and this is slant height, right? Now over here, height is given 21 centimeter and slant height, which is L, and this is H, which is given 28 centimeter, right? Now we need to find the volume of cone, so we can write volume of cone is 1 by 3 pi r square h, right? So this will be, now over here pi is not given, so we can take pi as 22 by 7. So this will come out to be 1 by 3 into pi is 22 by 7 into r square is, we need to find, right? And h is given to be 21, right? So let's see how we can find the r now. For r, we can use Pythagoras theorem. We state that L square will be equals to r square plus h square. So L over here is 28 square, and r we need to find, h is 21 square. So this will come out to be 28 square minus 21 square, which is equals to r square. So 28 square we need to find. What is 28 square? So if you do, it will come out to be 784, take away 21 square. So 21 square is 441, which is equals to r square. Now we need to subtract 784 and 441. So this will come out to be 343. So this means we have r square as 343 centimeter, right? Now we can write it over here and find the value. So this will come out to be 1 by 3 into 22 by 7 into 343 into 21, right? Now this will cancel with this and this will cancel with this. So we are left with 22 times 343. So if you calculate 22 times 343, so this will come out to be 7,546 centimeter cube. So we can say that the volume of cone is 7,546 centimeter cube. So this is how we can use the concept to find the solution to different type of questions. So let's discuss the next example, which is example number 2 and also the last example of this video. Now the example says that Monica has a piece of canvas whose area is 551 meters square, and she uses it to have a conical tent made with a base radius of 7 meter. Now assuming that all the stitches, margins and the wastage incurred while cutting amounts to approximately 1 meter square, we need to find the volume of tent that can be made with it. So let's see how we can solve this question. First of all, we need to write the dimensions, what is given. So we can say that area of piece of canvas Monica has is 551 meters square. Now she uses it to make a conical tank and it has a base radius of conical tent should be 7 meter, right? And while cutting and stitching, the wastage is 1 meter square. So we can say that wastage while, let's say, cutting and margin amounts is 1 meter square. So this means we are left with left area of canvas is 551 minus 1, which is 550 meters square, right? Now we need to find the volume, right? Now, so volume of cone is 1 by 3 pi r square h, right? So we have r over here 7 meter. However, we need to find h. So let's see how we can find the h using the area, right? Now area of canvas is 550 meters square, and this is the curved surface. Let's say we have a cone like this, right? and this is radius r, and this is h, and this is L. Now when you draw a canvas tent, conical tent, so the base is always empty. We need not to cover the base. So it's only the curved surface area, right? So we can say that the curved surface area of cone will be equals to pi RL, right? And this is what? 550. So we can put 550 will be equals to pi RL. So this will be 550 equals to 22 by 7 into R is 7 into L, right? So this and this get cancelled. So this will come out to be, L will come out to be 550 by 22. So it will be 11 2s are 1150, 2 1s are 225. So we have L as 25 meters. So we have L as 25 meter. Now we can find H using Pythagoras theorem. So we can say that L square will be equals to R square plus H square. Now L square is 25 square, which is equals to R square is 7 square plus H square. So H square is 25 square minus 7 square. So H square is now 25 square is 625 minus 49. So when you do this, this will H square will come out to be 576. So H will be under root of 576, so which is 24 meters. So we have height as 24 meters. Now this will come out to be 1 by 3 into pi is 22 by 7. R is 7 square times 24. So this and this will cancel. So 3 1s are 3 8. So this will come out to be 22 times 7 times 8. So this will be 22 times 56. So this will be 1232 meter cube. So this is the volume of the conical tent that can be made. So this is how we can use the concept of volume of cone to solve different types of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.